Hello, welcome back to Math 8. This is a video over Unit 6, Section 5, and we're going to be talking about the introduction to scientific notation. And our objectives today, we want to convert very small or very large numbers between scientific notation and standard notation, okay? And then we want to order and estimate products and quotients of numbers written in scientific notation, okay? So the first thing I want to talk about is standard notation versus scientific notation and the point of this. Up here, let's write that the point of scientific notation is a way to write big and small numbers, okay? And when I'm talking about big numbers, I'm talking about huge numbers, okay? And when I'm talking about small numbers, I'm talking about like really, really, really small numbers, okay? So now I want us to think of a real-world example when we're talking about really, really big numbers and really, really small numbers, okay? So let's think of a big number first. And for a big number, I want us to think about the distance across the solar system, okay? And so in this one is about 7,444,000,000 miles. Okay, this is a huge number, all right? And we could talk about a bigger number, like we could talk about the distance across the Milky Way, but like that's an absurdly big number, okay? And so what we think about here is this number is extremely large, okay? And if we wanted to operate with this number and figure out certain things, then writing this number out so many times is kind of a pain, okay? This has 10 digits associated with this number, okay? And this is in standard notation, okay? So I'm going to write that over here. Whoops. That this is standard notation, okay? And that's just how we typically write numbers, all right? But if I wanted to talk about something in scientific notation, okay, so scientific notation, all right, then what I would do is I would rewrite this as 7.44 times 10 to the ninth power, okay? And what I have here, okay, this is a little, if you've never seen this before, this might be a little confusing. You're like, how did this happen, okay? These two numbers mean the exact same thing, okay? What this allows me to do is to write this very large number as a small number times a multiplier, okay? And so if I think of 10 to the ninth power, okay, then really all I'm doing is this. I've got 7.44 times 10 to the ninth power is really times a billion, okay? So that'd be a 1, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, and when I do this, realize that when I have the ninth power, what I've done is I've got 9 digits, okay, past 1, all right? And if I take 7.44 times a billion, it's going to give me 7,444,000,000 miles, okay? And that's what we've got, okay? And one way to, and we'll talk more about how I go in between these two, but now let's talk about a really small number, okay? So a small number. And one small number that I think about is your chances of winning the lottery, okay? So your chances of winning, and let's do the Powerball, doesn't really matter which one we do, Powerball or Mega Millions, is 1 out of 292,201,338. Okay. And what I'm going to do is I'm going to plug this number into the calculator and do the division, okay? So this is your percent chance of winning in fraction form. Let me do the division here of these two numbers to find a decimal form. And that's going to give us 0. Hold on, what do we got here? 0, 0, 0, 0, 0, 0, 0, 0. 1, 2, 3, 4, 5, 6, 7, 8 zeros. And then the numbers start happening, and it's going to be 3, 4, 2. Okay? This is a really small number, okay? And this is the chances of winning the Powerball, okay? Powerball lottery, okay? So essentially what you have here, when you have this really, really, really small number, what this becomes is it's like so small that it's essentially 0. When you have 8 zeros and then your numbers start happening, that's a really low chance of you winning the lottery, okay? So, you know, winning the lottery probably isn't your best investment. However, you can't win if you don't play. And when the lottery is like, you know, at least $500 million, then, you know, then I'll buy a ticket just to see what I can do. So, but yeah, pretty low numbers, okay, of winning the Powerball. You know, if you track it each week, not many people, you know, every time they do Powerball, they do it twice a week, every Wednesday and Saturday, and hardly anybody ever wins, okay? And so the pot keeps getting bigger and bigger and bigger until finally someone wins. So I would say every now and then, you know, probably once every couple months, somebody will win the Powerball. Sometimes it goes as long as 6 months, and that's when the pot gets really big. So, but that's the idea. All right, so this is a really, really, really small number. Okay, now this is in standard notation. Okay, so this right here is standard notation. All right, with all those zeros, okay? Now, if you actually go into your calculator and you do this, and this is what I ran into, 1 divided by 292 million, this comes out in your calculator in scientific notation because this number is so small. And what you would do is you would write this. You would write 3.42 times 10 to the negative 9 power. This is in scientific notation, okay? And so, you know, these numbers aren't the smallest numbers that I could think of, and they're not the biggest numbers that I could think of, but they're pretty darn close, okay? When you have a number that's this big and that's this small, you can write it in scientific notation, okay? And what you're really doing here, all right, is you're really doing 3.42 times 10 to the 9th power is really 1 over 10 to the negative 9th is really 1 over 10 to the 9th power, okay? And so essentially what you're doing is you're dividing by a really big number, all right? And over here, let me rewrite this out. It's really doing 3.42 divided by a billion, okay? And that's pretty crazy, okay? And this is just going to give you a really, really, really small number, okay? And so you're just expressing this number in a different way, okay? And so what we want to be able to do is we want to be able to convert these numbers and do this, okay? Now, one thing I want you to do, when I take a look at this very large number, you have standard notation and you have scientific notation. These two things mean the same thing. Now, what I want you to do is this, okay? I want you to put a decimal place right here. This is where your decimal place goes, okay? Notice that all of a sudden your decimal place is right here, okay? And I want you to count how many spaces we go left, okay? So converting from standard notation to scientific notation means I'm going to do this. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, okay? I have 8 decimal places that I move over to the left. Okay, notice that 8 is my exponent here, okay? Now, if I go over and I take a look at a very, very small number, And notice how my decimal place is right here at 5.2. Okay, so what I end up getting is this. If I move my decimal place to the right, 1, 2, 3, 4, 5, 6, 7, notice how we have -7. Okay, so let's take a look at scientific notation. So it says it's a way of writing numbers as the product of a number greater than or equal to 1 and less than 10 and a power of 10. So notice that notice where my decimal place is, okay? Notice that my decimal place has one unit to the left, okay? So my decimal goes here, and that this number is between 1 and 10, okay? So I have one decimal place to the left, okay? And that's going to be the same case here and here, okay? Notice how all those numbers are the same. Notice how that occurs here as well and here, all right? So you got, 7.6 is between 1 and 10. Same thing with 5.2, that's between 1 and 10, all right? And then a very large number has a positive exponent. And a very small number has a negative exponent. Okay? Now, if we wanted to convert this into, from scientific notation to standard notation, I simply just do this. All right? So if I take this very large number, 7.85, and I wanted to convert this into standard notation, notice how I have 5. 5 is my exponent, okay? And what this means is that we're going to move the decimal 5 spaces right, okay? So this is the strategy we're doing, all right? So what I would do is I would do this. I got 7.85, and I'm going to move my decimal place 5 spaces to the right. So I'm just going to count 1, 2, 3, 4, 5. And that's my new decimal place. And then I have to fill this in with zeros. Okay? So on each little curve, okay, is where a placeholder goes. So now I have this. I have the number 785,000. Okay? And that's my number in standard notation. Okay, and I can do the same thing over here for a very small number. Okay, and let me write this out, 6.012 times 10 to the negative 6. What this means, the negative 6 means I'm going to move the decimal 6 spaces to the left. Okay. So that's important that we understand, we see that. All right. So what I'm going to do, if I'm going to do this, I'm going to do 6.012. Leave some space over here because I'm going to then do 6 spaces to the left. I'm going to go 1, 2, 3, 4, 5, 6, and that's my decimal place. Okay. And then I fill it in with zeros. Okay, I'm going to put a 0 out here. So the number in standard form is going to be 0. How many zeros we got? 5. 1, 2, 3, 4, 5, and then 6012. Okay, and this number here is in standard form. Okay? Okay, so one thing we can do with scientific notation is we can add, subtract, multiply, or divide. Okay? And so what this allows me to do is then say, in this case, airplane travels at a speed of 1.1 times 10 to the 6th feet per hour. This plane logged 1.02 times 10 to the 5th flight hours in its service life. Estimate how many feet the plane traveled throughout its service life. Okay, and what we can do is this. We can do 1.1 times 10 to the 6th times 1.02 times 10 to the 5th, Okay, we just multiply those numbers together. When I do this, I do 1.1, this number, times 1.02. And then so I can multiply these numbers together. And then I can multiply 10 to the 6th times 10 to the 5th. Okay, and so 10 to the 6th times 10 to the 5th, we can do those as well. So let me do 1.1 times 1.02, 1.1 times 1.02, and that's going to give me 1.122. Okay, and you could estimate this and just say, well, really this is 1 times 1, which is just 1. But since we have calculators, we can just do this, all right? And then times 10 to the 6th times 10 to the 5th. Remember, if I'm adding numbers with common bases, or multiplying numbers with common bases raised to an exponent, I just add my exponents. So this is then going to be times 10 to the 11th power, because all I'm doing is doing 6 plus 5 to give me 11. Okay, and that number goes there. So this is my answer. This is feet. Okay, now let's think about this. If I wanted to change this into standard notation, I would take 1.122 and move my decimal place 11 units right. Okay, and so watch what I do here. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and put my decimal place. I'm going to fill this in with zeros. 1, 2, 3, 4, 5, 6, 7, 8. And so we have the number 1, 1, 2, 2, 0, 0, 0, 0, 0, 0, 0, 0 feet. All right, well, that's how many feet? 112 trillion feet. That's a lot of feet, okay? That's a really, really big number, okay? I don't want to write this each time, okay, and operate with it. I simply can just multiply these two numbers using my properties of exponents to do so, okay? And we're going to get something in scientific notation, okay? We can also divide, okay? So estimating quotients. In 2011, the United States consumed more oil than any other country, using about 1.895 times 10 to the 7th barrels of oil per day. In the same year, Argentina consumed about 6.8 times 10 to the 5th barrels of oil. Estimate how many times more barrels of oil the United States consumed than Argentina. And so all we would do is we would take this number here, 1.895 times 10 to the 7th barrels per day. And what we can do in this problem that we didn't do on the last problem is use estimation. So thinking of this number, 1.895, that number is really close to 2, all right, times 10 to the 7th barrels per day. Okay, over here, 6.8 times 10 to the 5th, 6.8 is really close to 7 times 10 to the 5th. Okay, and so we can just estimate here. And if I want to do this, I would do division, and I would do 2 times 10 to the 7th divided by 7 times 10 to the 5th. Okay, and so if we do 2 divided by 7, that number we do want to actually operate with. So 2 divided by 7 gives us, so do the division on this, which is 0.2857 times 10. And here we would want to subtract our exponents. So 7 minus 5 gives us 2. All right. And then what I'd want to do here, if I'm moving something to the right, all right, if I'm moving this number, so after you do this operation here, what ends up happening is, like, if I'm moving this exponent or this decimal place to the right, so if I move decimal to the right, okay, I subtract an exponent, a number from the exponent. Okay, and so what I would end up getting here is I'd get 2.857, times 10 to the first. Okay, and really then this would be, that would be my answer. Okay. All right, hope you enjoyed this video, and we'll talk soon. See you later. Bye.